All right, so today, okay, we are going to introduce you to graphing trig functions. All right, we're going to go through all 6. Some we're going to stress more than others. Some are related to others, so over time we'll do that. So basically the instructions in this tells you to go to desmos.com. If you do that, it's basically a graphing website where you can sketch a lot of things. So we're going to simulate it with the graphing calculator. So we're going to start with y equals sine theta. All right, so when I graph it, all right, okay. All right. So basically, you see what it does. It's basically a wave. All right. And if you graph those points, pi over 6, 1 half, pi over 4, root 2 over 2, pi over 3, root 3 over 2, you'll see they're all in that graph, which verifies that it's a sine graph from the last couple of weeks working with the unit circle. All right. Does it repeat itself almost like a cycle? The answer to that is yes. All right. It continually does the same thing over and over again. All right. So trig functions are an example of what we call periodic functions. A function returning the same value at regular intervals, which means over and over again it'll do the same thing. What are the first 6 letters of the word periodic? Well, if I count correctly, which hopefully I can do, that would be period. Okay? Which we'll use later to describe the graphs. Now we'll talk about alterations. In other boxes, enter the following: y equals sine x plus 1 and y equals sine x minus 1. So I'm going to do the same thing on my graphing calculator that you're hopefully doing on your computer. All right, and I hit graph. So there's my original blue. The red one is plus 1. All right. And then what appears on mine as a green one is beneath it. Other than that, the shapes are exactly the same. They've been raised up or lower. So basically, when we add numbers outside, it creates what we're going to describe as a vertical shift. If it's a positive number, it will raise up. If it's a negative number, it will raise down. In this case, since the number we added and subtracted was 1, that means it's going to raise it up 1 or down 1. So that creates a vertical shift. Now says in other boxes, enter the following: x plus pi, x minus pi. So delete those. All right, and sine of x plus pi and sine of x minus pi. So again, we're adding and subtracting, but this time we're doing it inside parentheses. So let's see what that does. So there's my sine x, what we would call the mother function from last year. Okay. So basically the blue is the mother function. The green's a little different. So basically what has occurred is, I changed my window. Might be easier to see. There's sine. All right. So there's the plus 1, or there's the regular one without the plus 1 and minus 1. And then you'll notice it's the exact same, but basically it's been moved over. So if we look, all right, if we look, two things. One, they're the same function in case you didn't notice. But basically, here's where sine x popped out, and here's where both sine x plus pi and minus pi. So they shifted over. One is shifting it to the left, one is shifting it to the right. All right? So what impact does this have on the graph? Specifically, how do these compare with the ones from part A? What is the difference between adding something without? All right, so this created a horizontal shift. All right, this created a horizontal shift, which we often describe as a phase shift. All right? So when there's parentheses, all right, a number is being added or subtracted, it's horizontal. And when there's no parentheses, all right, it's a vertical shift. All right. So now it says delete these four, leaving just y equals sine x. So I go back and I delete everything else. Okay? So now we're going to graph them. And to make it easier on you, I'm going to show you one at a time. So here's 2 sine x. All right. So there's 2 sine x. There's sine x again. Graphing in all its glory. The advantage to you is it doesn't have to regraph. And now, ooh, look at that. It's wicked. All right. It's wicked. It's steeper, right? All right. So if we go back and change our window, and now we'll make this a little bigger so we can see. All right. So there's again the sine x. All right. And then there's sine of 2x. And you'll notice, okay, the zeros are still the zeros. So there's no horizontal shift in this one. All right. But, okay, and they're still reaching their maximums and minimums at the same spot. The problem is it's going higher and lower, and that's what we call amplitude. All right. So y equals 2 sine x increases the height of each curve, or the depth of each curve. Now, if I go the opposite way, y equals 1/2 sine x. All right, so, but I'm not going to use 1/2. I'm going to use 0.5 sine x to make it easier to put in my calculator. And there's the graph again, okay? So there's sine x. And then there's 0.5 sine x. All right, so again, notice the intercepts where it hits 0 stays exactly the same. That's important. But because it's a fraction, all right, because it's a fraction, instead of going higher, it's actually going lower. All right, so basically this decreases the height. All right, so a fraction decreases the height or the depth. All right. Now when we do negative sine x, so I'm going to do just negative sine x. All right, I'm going to graph them both. And then there's negative sine x. Now if you look, it's still 0. Okay, but the difference is instead of going up like in the original, now it goes down. And that's what the negative does. It creates, as you know, a reflection. So we have negative sine x. All right, so we have negative sine x. So basically the negative flips it. All right, and you learned last year that that's a reflection. All right. What impact does this have on the graph? Specifically, how does the one with the integer compare to the one with the fraction? How does the negative compare to the positives? So when we have a number in front of sine, or in this case sine, but all right, what it will do if it's greater than 1, all right, it increases. All right, we're going to use a word here that's going to come up soon. It's called amplitude. All right, If it's less than 1, it decreases what we call the amplitude or the height. All right? And then when we have a negative number, it reflects it. All right, it flips everything. Leave the y equals sine x and the y equals 2 sine x, deleting the other 2. Okay, so I'm going to come back here. All right, and this is 2 sine x. All right, and then it wants me to graph sine of 2x. So now notice, okay, the 2 isn't in front of the whole thing. That's what gave us the amplitude. Now it's in front of the variable. So there's the sine x once again. There's the sine of 2x, which no doubt has the same amplitude, so that's the red one. So we already know that that just increases how high we go and how low we go. But it keeps the zeros, there's no shift. Now here is, all right, sine of 2x. Wow, that's moving quick. Okay, well, what causes that to move quick is it's going through its cycle quicker. So basically what I'm going to do is I'm going to get rid of the 2 sine x so we can compare them specifically. So here's the sine of x moving kind of slow. It's an older graph, so it takes a little time for it to get started. Just kidding, it's not older. That's ageism, and obviously all these problems are millennials. So, all right, what happens is if you look, okay, for every one of that, it's going to. If you look at the width, it's just increasing. So what that does, all right, what a number does in front of it, difference. All right, the difference between sine of 2x and 2 sine x is it affects the cycle, which I told you this word will come up, the period, or the time it takes. All right, now, next to last one, so there's sine x. I'm going to get rid of the sine 2x, and I'm going to put the other cosine graph, okay? So there's the sine of x once again. All right, and now cosine. Notice it's in red. It's the exact same graph. Okay, it's the exact same graph. All right, but if you notice, well, I put it on my computer screen, sine starts at 0, cosine instead starts at 1. And that's because on the unit circle at the origin at 0, cosine's 1. All right, whereas sine is 0, so that's the difference. But other than that, the shapes are the same. All right, so how do they compare? They're the same shape. All right, different starting points. So same shape, different starting points. All right. Sine tends to start at 0 unless there's an amplitude or unless there's a vertical shift that we took. Cosine, when there's nothing else going on, starts at 1. And now the last one, tangent x. Okay. So the instructions are saying in the third box graph the following: y equals tangent x. I'm going to leave sine and cosine because I realize they're pretty much the same. And here comes tangent x graph. Woof. There we go. And what happens with tangent is it just keeps increasing. And then it starts down low again and then just keeps increasing. So it's not continuous. That is because of the existence of 0 in the denominator. Remember, tangent with the unit circle was y over x. And if the x was 0, okay, it didn't exist. Well, that's what's happening here at all these spots. And we'll go through when we go through the graph later in the week. X is 0. So what tangent x has that the others don't have is values that do not exist. D&E. And from Algebra 2 last year, that means we're going to start talking about asymptotes. All right, we're going to start talking about asymptotes. All right, so hopefully that gets you through the introduction. All right, we'll post another video shortly about the remainder part of the packet.